Good afternoon, everybody. Thank you for being here at Geotab Connect 2020. Our next session here is hosted by two of our European colleagues. We have Yvonne and Miguel, who are going to talk about new mobility schemas. The stage is all yours.
Thank you very much. I think, have the micro. Thank you very much. Thanks, guys, for being here. It's the second day, it's the afternoon, so thanks for the effort. The title of the presentation is a bit funky, so let me go through the content that we are really going to present today. We are in a very disruptive moment in the mobility industry. There are many trends in urban mobility. We are going to go through these trends, and we are going to explain the reasons behind these trends, why this is happening right now. And we are going to talk about several use cases for the car sharing industry. Both of us come from Madrid, and Madrid is a paradigm of a city where these new mobility trends are flourishing. And then we wanted to end up with a scoop, but we just realized that a colleague of us presented this previously today. But anyway, we will go through kind of a scoop in the product area. So first of all, the context. Why all these changes are happening? Basically, because of these four different reasons. First of all, the boost of the cities. 55% of the population lives in cities right now. And according to United Nations, we will have up to 80% living in cities in a few decades. The second reason is the regulation. Regulation is now much more protective with their citizens. We have emergency call that is mandatory in Europe for all the vehicles that were sold after 2018. And we have the GDPR. The GDPR is a regulation that basically protects the privacy of the citizens, of the consumers. Also, the OEMs are trying to change the DNA. They don't want to be car manufacturers anymore. They want to provide other services, not only maintenance, not only financing, not only insurance. They want to become mobility providers. Most of them are trying to go in that direction, and they are trying to change the way they work, the way they operate. And of course, the technologies. Technologies are evolving very, very fast. We have new electric engines. We have batteries that last longer, and they are much easier and much faster to charge. We have artificial intelligence. We have ADAS. We have sensors. You name it. And most important thing is that there is adoption of these technologies. That's the important thing. You may have a very disruptive technology, but if the consumers, if the companies don't adopt that technology, it doesn't matter. So we always mention the example of the Google Glasses. The Google Glasses, it was a very great product. Everybody loved it, but nobody really adapted. So at the end, Google ended up discontinuing that product. No? Now we're in a different stage. The companies and the customers are really adapting these technologies. And all this ecosystem is basically making these 5 big trends in urban mobility happen. And there is a lot of consensus in these trends. There is some debate on when are these going to be massively adopted, but everybody you talk in the mobility industry, they agree that the mobility will be shared, electric, connected, autonomous, and integrated. Shared because citizens in large cities, especially millennials, they don't want to own a vehicle anymore. They don't want to pay for the insurance. They don't want to have a parking. They don't want to take care of the maintenance. They want to get the vehicle when and where they need it. Electric. So air quality is a big issue in large cities. Many of the important cities in Europe are putting low emission zone. And if you want to move and park with freedom in those cities, you need to have an electric vehicle. Moreover, the total cost of ownership of having an EV will be much more efficient than an internal combustion engine in 5 years. Connected. This is not a trend. This is a must. This is an enabler. No? All the digital services need a connectivity. So maybe 10 years ago, we need to explain why a vehicle needs to be connected. Not anymore. Autonomous. Neil mentioned yesterday that we don't see fully autonomous vehicle happening in the short term. Yes, I fully agree with that. But most of the OEMs are already integrating ADAS and systems that are helping to drive the vehicle already. And the last one is integrated. So people are willing to use different transportation systems. They don't need to use just one. They can combine public and private transportation. They can go with their own car from the surroundings of a city to a bus station and then get a bus. Or they can go to the metro and then rent an electric scooter. And they now have a lot of appetite towards applications that make this easy for them, easy to consume. And there is a clear industry that is grouping all these trends, and it's the car-sharing industry. As we mentioned, both of us come from Madrid, and Madrid is a good example of a city that is pushing the car-sharing industry. We have 5 different companies that are delivering these services, and they are using Madrid as a lab. They are testing these technologies, and they are testing how a car-sharing industry should operate. The reasons behind that are basically 2. The first one is that they have very complex processes. They are super complex. Every time the vehicle runs out of battery, they need an operator that takes the vehicle, move it to a charging point, to a depot, get it charged, and turn it back to the city. This is complex and not cost efficient. And the second reason is that users are not treating the vehicles as their own. So they have damages, they have faster degradation, they have fines, car towing, and this is the main reason why these companies are not profitable yet. And they are using Madrid because the size of the city is good, there is a low emission zone, there is a lot of appetite from the citizens, and they are testing new solutions. What we are doing, we are helping many of these companies with the Geotab technology and with our partners to overcome these several challenges that they have in their daily operations. We have identified several use cases. Some are very straightforward, like location of the vehicle, and some are very, very challenging and very tricky, no? Like the minor damage detection. They have an issue when a vehicle is heated and they have a small crash. These companies cannot identify who was the user who caused this damage. So now Miguel is going to go through all these use cases that we are working with these companies. All yours.
Thank you. All right, so the most obvious use case is probably accurate location, GPS. As an end user of a car-sharing company, you need to know where the vehicles are parked, and so does the car-sharing company. The movement of the vehicle is tracked using the Kublogen algorithm, and so then you know when a certain event happened, a possible accident or a overspeeding. What is interesting for a car-sharing company is that the movement of the vehicle can be tracked even if ignition is off, hence the car is being towed, which is something that unfortunately happens quite often, that people will park the car where they shouldn't, and hence it comes the tow truck. Because as Ivan mentioned, sometimes we end users of a car-sharing company do not behave as we should, which brings us to the next use case, driving profiles. Are your drivers driving aggressively? Are they wearing their seatbelts on all of the times? Are they overspeeding? Or maybe even are they disabling the eco mode? Understanding how your drivers behave is key, not only for safety reasons, well known to everyone, but also for efficiency, particularly on those cases when at least some cars are electric vehicles. Now, if you understand how your drivers behave, you can plan loyalty programs, you can reward those drivers maybe with a discount that do behave properly. And it's important to note that the personal information of the driver does not need to go into my Geotab. You can always leverage the API and have it integrated with your backend. Another important use case is vehicle status. And by this I mean maybe there's an engine alert showing up in the dashboard, maybe an issue with tires pressure, doors opened with no one inside the car, or maybe there's an upcoming maintenance. As an end user, it's very frustrating to open the app, book a car, walk to it, only to find that it cannot be driven. The car doesn't work. So better to get a notification when any of this happens, an act, maybe remove the vehicle from the list of available vehicles before the end user goes there and complains and report this as an issue. A similar case happens with the 12-volt battery. Electric vehicles do not only have the EV battery, the one that's used for traction, the high voltage one. But they also have, as many other vehicles do, a 12-volt battery, which is used to open the doors, turn on the radio, turn on the ECUs. Now, the car will not work if this battery is not working, even if the EV battery is fully charged. So better to have this key component also monitored. The EV battery also needs to be monitored, of course. As an end user, you want to know how much remaining battery is there in the car you want to book. And the car company needs to ensure that the cars are returning to base to get charged. The charging status can also be monitored, so whether or not the car is plugged or unplugged, and then you can know the current level of battery while charging the vehicle. Now, by combining both, the EV remaining battery and the charging status, you can work on improving the efficiency of the whole process. That's a car needs to be charged, get it back to base, have it charged, return it to the street. That way, by improving the process, you can maximize the number of cars on the field, which is something that's good for both the end user and the car sharing company that can maximize revenues. I'm talking about maximizing the number of cars on the field. There's plenty of information when you're using a telematics solution. You get times and locations, you know when and where the trips started and ended. And you have reports, you have alerts, you can have business intelligence applied to this in order to ensure that there's always a car when and where needed. As an end user, you open the app, try to find a car, you find there are no cars around you, but there are a lot of cars in a far region of the city that haven't moved for days. That happens, and let's try to avoid that. Just two more use cases. This one's around collisions. You all know that there's an accelerometer on the Go device. When there's a significant collision, an accident mode will be triggered. You will have a lot of data sent to the platform. You get a notification, and then you can analyze the circumstances around that accident. Speed and location and RPMs and the accelerometer pattern in such a way that you can understand how it happened. Now, this is a very well-known feature of the Geotab solution. It's triggered when there's a significant collision, particularly above 2.5 G. But what happens with minor collisions? Minor collisions may be resulting in a minor damage to the car, maybe while parking, an end user, there's a damage, there's a new dent. And the car sharing company will only find about this new dent when the car returns to base, after several trips made by different users. They will not know who was responsible for that new damage. It's a complex issue to solve technically because most minor collisions are very hard to distinguish from other acceleration patterns, a harsh braking, or maybe a speed bump. So we are at Geotab working on a data science project, leveraging machine learning techniques, trying to identify as many of these patterns as possible so that we can notify to the car sharing company that something happened, that possibly a minor collision happened at a certain time. Now, all the other use cases are already implemented, available in the platform. This one is not, it's work in progress. Expecting to have some nice results during this year. If you are interested, please get in touch. We can provide early access. We can leverage some of your real cases so that we can train further the algorithm. So please reach out. And there's one last use case that we haven't mentioned it, and Ivan will tell us about.
So yeah, for sure, many of you will be wondering, where is the remote door unlock? We know this is a strategic piece for the car industry, and the scoop is that the product team has been working on this for several months. We spent some time analyzing the different options, and we now have a product that is going to be released soon that we think is the right one for the industry. It's a very low-cost solution. It's very scalable. It's secure because we use the electronics of the original key. And the main message is that it's compatible with all the make and models. We will be announcing this officially in a few months. But if you want to test it, if you want to try it, if you have a potential customer from the car industry that is willing to test the remote door unlock and immobilization, please reach out to us. We will get in contact with the product team in Waterloo, and we will support you in the pilot. That's basically it. What we wanted to discuss today. Thank you very much. If you have any questions, we're all yours.
Require like mobile app integration, or sort of what are the other pieces in that?
Yes, it's either through a smartphone app in the mobile or the user, or can be used with another card, proximity cards, NFC or Bluetooth. And basically, we connect to that box, and in that box, we have the original car key that basically opens the vehicle through radio frequency. It's very secure because once you are in the vehicle, you don't have the key to open and you could steal the car. So yeah. Okay. Thank you very much, guys.
Thank you.
Thank you.